Now let's look at the p-series and the harmonic series. The p-series is defined to be the sum of n goes from 1 to infinity of 1 over n to the p, where p is my exponent. So this is going to be 1 over 1 to the p, plus 1 over 2 to the p, plus 1 over 3 to the p, etc. Now, this is a p-series, and p is a positive constant. If p is 1, we see this reduces to our harmonic series. And I want to point out that the generalized harmonic series is equal to 1 over a n plus b. So if you see a series, sum n goes from 1 to infinity of 1 divided by a n plus b, you can say this is a form of the generalized harmonic series, and everything we say about harmonic series applies. Now, let's look at the p-series. The p-series converges if p is greater than 1, and it diverges if p is less than or equal to 1. Remember, p is always positive. So let's look at this. Does it converge or diverge? This is a p-series, and this is what you need to write. P-series n equals 1, and therefore it diverges. You can also say this is a harmonic series, and it diverges. Now let's look at this. This is a p-series, n equals 2. So by the p-series test, this converges. P-E-R. Now you notice I'm not asking you what these sums are. I'm just asking whether they converge or diverge. Now let's look at this one. 1 over n log n. Oh goodness. It looks like a divergent times another function. Let's see. It's similar to the divergent series, but we don't know what this 1 over log n does. And we can't just assume that it diverges. So let's do a test. For n greater than 2, let me let f of x equal 1 over x log x. For x greater than 2, which is where my sum starts, it is continuous and positive. Now let me see if it's decreasing or increasing. F prime of x is minus x log x. So minus 2 times 1 plus log of x. Let me rewrite this. Probably should have written it this way to start with. 1 plus the log of x divided by x squared log x squared. And I've got this great big minus sign out here. And this is always negative, so f of x is decreasing. So it satisfies the 3 conditions to do the integral test. So let me integrate. Now you notice my sum starts at 2, so I'm going to start at 2. From 2 to infinity of 1 over x, natural log of x, dx. Now, let me let u equal natural log of x. Du is, what is du? It's 1 over x dx. U of 2 is the natural log of 2. And u of infinity, now clearly I'm going to have to change my limits here. So this becomes the integral from the natural log of 2 to infinity of du over u, which is improper. So it's the limit as b approaches infinity of the integral from the natural log of 2 to b of du. That's not very legible, is it? Over u. I'm at the bottom of my tablet here. It's kind of hard to write. So this is a limit as b approaches infinity of the natural log of the absolute value of u, evaluated at the natural log of 2 and b. So this is the limit as b approaches infinity of the natural log of b minus the natural log of the natural log of 2. And this is infinity. And what that tells me is a series of the sum n equals 2 to infinity of 1 over n log n diverges.